With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. A ring of mass m and radius r is rotating in uniform magnetic field B, which is perpendicular to the plane of the loop with an angular velocity omega naught. Find the net ampere force on the ring and tension developed in the ring if the current I is in the ring, and the current and the rotation both are clockwise. So if you see, current is given, it is clockwise, and the rotation is also clockwise. Alright, so what we have to do, let us take a small element and see what is happening here. So if I take a small element of angle d theta, here this angle is d theta, so here the torque will be acting like this, here the tension force will be acting like this, right? T and T. So you can see here the tension force is T and T. So net tension force you can get, if you see, this angle will be 90 and 90. So this angle is, these two angles are 180. So this will be pi minus this. So there are two vectors of equal magnitude T, and angle between them is pi minus d theta. So if I write down the net the centripetal force here, right, that is because of this tension, the net tension force that is acting here, T net, it will be equals to 2T cos. We know that when the magnitude of the vector are equal, we write down 2a cos theta by 2. So here the magnitude of both the vector is T, so I will write down this. It is this. So it will be 2t sine d theta by 2. Since the angle is so small, so we will write down this sine d theta by 2 is d theta by 2. So it will be this. So let me write down this. Alright. Now, if you see here, the magnetic force. So as you can see, the current is in clockwise direction, and if you curl your finger from the current to the magnetic field, we know that the magnetic force, small magnetic force on a element, it will be, if you see, this is small element of d, if I write down dl, it will be r d theta, right? So I will write down, it will be I dl vector cross r vector, right? So just see here, dl cross r will be directed outward, right? So if you see outward, so we will just write down the magnitude. It will be I and into B. This. So df we got, it is BIR into d theta, right? So we got the forces. So if you see, the tension force on this small element is this, and the magnetic force is this, right? So if you write down the net force toward the center, that is dt net, right? That is this, right? And minus this small df force is equals to dm omega square r. So if you see here, the dm we have to write down by unitary method. Simply, if you see, total length is 2 pi r, right? So you can also see here the 2 pi angle is having mass m. So d theta angle will be having mass m by 2 pi into d theta. So you can just put the value m upon 2 pi into d theta. Alright. So we will write down the expression here. So we want this tension. So let me write down this as T dash only, the tension in the wire. So if you see, this is minus the magnetic force, it is BIR d theta is equals to omega square r. It is BIR plus m omega square r by 2 pi. Now you can take r upon 2 pi outside common here. If I take r upon 2 pi common here, I will write down it is m omega square plus, if you multiply here 2 pi, it will be 2 pi I b. This will be the net tension and answer of this question. If you see here the question, we wanted the net ampere force on the current on the ring and the tension developed in the ring. So if you see the net force, right, net force, you can see from the symmetry it will be 0, right, because the diametrically opposite point will experience the same df force, right. So net force here will be, net ampere force here will be 0, and the tension we already calculated, so net ampere force is 0. Ampere force from the symmetry it will be 0. Simple. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.